In this video, I'm going to give you an introduction to the basic definitions in trigonometry. In a previous video, kind of gave you an overview of the idea of trigonometry. Basically, we're using angle measures of right triangles to find lengths of sides. You're not going to be able to do that in this video. Okay, this video is just going to get the terminology down. I think you'll find the terminology is pretty easy to use, but you may find yourself wondering, why do I care? Why would I use this? Why does this help anything? And this video isn't really going to answer that question. So just stay with me though, learn the definitions, and I promise you, this has a pretty powerful use. So here's the idea of trigonometry. The idea of trigonometry is using angle measures of right triangles to find lengths of sides. And you're always going to be looking at one of the two acute angles, okay? So I talked about a tree problem, and there was a 70-degree angle in the right triangle and a 20-degree angle. You could use either one of those two angles, okay? What trigonometry is going to do is it's going to store all the different ratios, all the different relationships between side lengths of right triangles. But you're always going to be just comparing two sides at a time, okay? So there are three different rules, and those three different trig rules that we're going to be learning are going to involve any possible two sides of the triangle. Okay, so basically we're always looking at two sides and we're leaving one side out, and that's why there are going to be three different rules. Okay, I also want to introduce a symbol here. I don't think your book uses this symbol, but you're going to see this a lot when you take Algebra 2 and definitely all over the place in pre-calculus. It's this Greek letter, okay? This is the Greek letter theta, okay? And a lot of times they will use theta to represent an angle measure. Like you might use variables to represent lengths of sides. You might use theta to represent an angle measure. So you can see here I've labeled angle theta here. And again, if you don't like theta, you could put an X in place of it and it will do exactly the same thing. But I'm going to do the definitions with theta instead of X. But again, if you want to make this an X and you want to make that an X and that an X, totally okay. All right, here's the concept. The sine of an angle, S-I-N-E is how it's spelled, compares two sides of a triangle. You pick an angle, and it's the ratio, it's the fraction. These are all going to be fractions every single time. It's the fraction between the leg that is opposite the angle that you're looking at, divided by the length of the hypotenuse of the triangle. Okay? The cosine of an angle is going to be the length of the side that's adjacent to the angle you're looking at, the leg that's adjacent to that. We'll look at that in just a minute, over the length of the hypotenuse. And then the tangent of an angle, you're going to take the length of the leg that's opposite that angle and divide by the length of the leg that's adjacent to that angle, and that'll give you your tangent ratio. Okay? Now these labelings. When I'm talking about opposite and hypotenuse, you have to start with an angle, okay? And this changes depending on which angle you're using. It's always going to be one of the two acute angles in the right triangle, so either this one or this one, okay? By the way, cosine is spelled this way, tangent, T-A-N-G-E-N-T if you want the full word. Okay, if I'm starting with this angle here, remember that a side that's opposite an angle is across from it, and so that side there would be the opposite leg, okay, going across from the angle, opposite the angle. The leg that's adjacent to the angle, if you ever talk about buildings that are adjacent to each other, they're next to each other, angles that are adjacent share a side basically. Same thing here, a leg that's adjacent to the angle is next to the angle. So that is the adjacent leg, okay? And then the hypotenuse is always your longest side, it's always across from your right angle, okay? If I changed my angle position, those labelings change. Okay, so for example, if I went to this angle up here and I said, I'm going to make this angle X, let's say, the opposite side, the opposite leg would be across from X here. The adjacent leg is the leg that is next to it, and then the hypotenuse doesn't change. Okay, so really just the opposite and adjacent will change based on which angle measure you're looking at. That's the basic concept. Okay. So how does this work? By the way, I'm going to change this to X here. So you always take the sine or the cosine or the tangent of an angle measure, okay? And sometimes you'll actually have the angle measure, and sometimes you'll just have the name of the angle. So I want to start out with just a basic 3, 4, 5 right triangle, okay? And to do this, you need all three sides of the triangle in a lot of cases. So if you don't have all three sides, you might have to use the Pythagorean theorem to fill them in. All right, let's say that this is angle A, this is angle B, and this is angle C. Okay, here's how you find the trig ratios. Okay, sine, cosine, and tangent are always fractions. So if I ask you to find the sine of angle A, okay, sine is always the length of the opposite leg divided by the length of the hypotenuse. So you go to your angle, angle A, okay, and you go to the side that is opposite angle A, okay? The side that's opposite angle A has a length of 3. And then sine is the length of the opposite leg over the hypotenuse. The hypotenuse length here is 5, okay? So sine of angle A is 3/5, okay? What does it tell you? It doesn't really allow us to solve much. It's just using a definition right now, okay? If I wanted to find the cosine of angle A, that would be the adjacent leg divided by the hypotenuse. So I go to angle A. The leg that's adjacent to it is the leg that's next to it, that's 4, and the hypotenuse is still 5. So cosine of angle A is going to be 4/5, okay? To find the tangent of angle A, it's going to be the opposite leg divided by the adjacent. So you go to angle A, you go across from it, that's your opposite leg. It has a length of 3. You go back to angle A. The leg that's next to it, that's adjacent to it, has a length of 4, and we say the tangent's 3/4, okay? So that's the basic level, just finding fractions, okay? And again, it might be a right triangle you know, or it might be a right triangle that you have to fill in some side lengths on, okay? So let's try a couple with angle C, okay? If I wanted to find the sine of angle C, sine of angle C is going to be the length of the opposite divided by the hypotenuse. So we go to the side that's opposite angle C, that's 4, okay? And then we go to the hypotenuse, and that's 5, okay? Interestingly, the sine of C is the same thing as the cosine of angle A, because we flip-flop those two side lengths, okay? The cosine of angle C is going to be the adjacent over the hypotenuse. So you go to angle C, the leg that's adjacent to it is 3, and the hypotenuse length is still 5. And if I want to find the tangent of C, we go to the opposite side, which has a length of 4, and then the adjacent leg, which has a length of 3. Okay? Now, this can get more complicated. Let me just do one that's slightly more complicated, and then we'll close out this video. All right, so I could give you a right triangle with side lengths of 1, 2, and that's it. And I can also just label an angle. I could use a variable. So I could say this is an x degree angle here, and that's the one we're going to look at. And I could ask you to find the sine of angle x. So we're starting with this angle. Remember, it's always going to be one of the two acute angles. You're never going to use the right angle for this labeling process. And sine is the opposite leg divided by the length of the hypotenuse. So the opposite leg is across from x, it's 1. I wasn't given the hypotenuse, okay? So I'm going to have to do the Pythagorean theorem here. 1 squared plus 2 squared, and then take the square root, and that's going to be the square root of 5. Okay, so the hypotenuse is radical 5. You should rationalize your denominator. Okay, 1 over radical 5, we can multiply top and bottom by radical 5. That's going to be radical 5 over 5. Be careful, a whole number does not divide into a radical, so it just stays radical 5 over 5. Okay, if I wanted to find the tangent of angle x, that would be the opposite over the adjacent leg. That'd be 1/2. Okay, if I wanted to do another angle over here, maybe call it angle theta, and I wanted to find the sine of angle theta. That would be opposite over hypotenuse. That's going to be 2 over radical 5. And again, you want to rationalize the top and the bottom there, and you'd get 2 radical 5 divided by 5. And 5 doesn't go into 2, and there's no GCF that divides out, so you just leave it in that form. Okay? Oh, one other thing I wanted to mention here. Very often, you're going to see the term Sohcahtoa used. And I have a great story I normally tell, but it's just not going to work on video. So ask people in the honors analysis class if you want to hear the story. Anyway, the phrase you'll hear a lot of times is Sohcahtoa. Okay? It's not in a lot of textbooks, but most teachers use it. Okay? So if I talk about your Sohcahtoa rules, it's a quick way of remembering sine, cosine, and tangent. So is sine. Sine is opposite divided by hypotenuse. Ca is cosine. That's adjacent over hypotenuse. Okay? And then tangent, toa, is opposite over adjacent. Okay? So if I talk about Sohcahtoa, that's what I'm talking about. So we'll look at some actual applications in the next video.